Hello everyone, welcome to the subject EIE567, Wireless Power Transfer Technologies. I'm Dr. Lin, the lecturer of this course. This video will introduce the content to be taught and the subject arrangement in this semester. Wireless power transfer, WPT for short, has two types, the inductive and the radioactive WPT. First, let's take a look at the inductive WPT. The science behind this technology relates to Ampere's law and Faraday's law of induction. Ampere's law tells us if you have the constant current, either on a straight wire or a solenoid coil, constant magnetic fields will be induced around them. However, these constant fields cannot support wireless power transfer. 5 years later, after the invention of Ampere's law, Michael Faraday invented Faraday's law of induction. That tells us the time-variant magnetic fields will create an electromotive force. Suppose you have a primary coil with the time-variant current flowing on it. The time-variant magnetic fields will be around. If you put the secondary coil with the fields passing through it, the energy will thus be transferred from the primary coil to the secondary coil wirelessly. So this is the fundamental physics of the inductive WPT. Inductive WPT has been successfully commercialized, in particular for personal electronic devices. You have probably used the wireless charging pad for your mobile devices or electrical toothbrushes. In future, the wirelessly charged electrical cars are even possible. Imagine if you park your car in a WPT-enabled parking lot, and your car will be automatically charged if required. It is very cool, isn't it? It should be also noted that the inductive WPT only supports short distance applications. If you want to charge something that is meters or even kilometers away, radioactive WPT is alternative technology. Radioactive WPT is based on electromagnetic waves, which was first described by the Maxwell equations invented by James Maxwell in 1864. Maxwell equations tell us the relation between the time-varying electric field and magnetic fields. The time-varying magnetic fields will induce a time-varying electric fields. The time-varying electric fields will further induce the time-varying magnetic fields, such that the electromagnetic waves will propagate from the origin to a very long distance. A super long distance radioactive WPT application is a solar power satellite. This system will capture the solar energy in the space and transfer the energy through the antenna via microwave beams to the Earth to support our daily use of electricity. Many big powers in the world, including China, are investigating this system to deal with the energy crisis we are facing today. By the year 2050, gigawatt-level electricity power will be transferred from the space to the Earth. We look forward to the successful development of this project. Another feasible commercialized application based on radioactive WPT is wireless charging for our electronic devices, for example, mobile phones. Let's take a look at the video demo from Xiaomi. It's air charge technology.
What does charging look like in the future? Imagine walking into a room and your phone automatically begins charging. Today, we're bringing this closer to reality. Introducing Mi Air Charge technology. Using a system made up of 144 antennas, this transfers energy to the smartphone in the form of an extremely narrow millimeter wide wave beam. Within a few meters, we offer a 5-watt remote charging solution. Taking that a step further, it also supports multi-device charging, charge on the move, while gaming, or even when something's in the way. Looking ahead, smart living goes truly wireless. This isn't science fiction. This is technology. Me air charge technology.
This course will study the theory behind both the inductive and the radioactive WPT technologies. So this is the subject arrangement in this semester. We will have 21 hours interactive lectures and tutorials, and we will have a text for 3 hours. Note that we don't have the final examination, so all the assessments are continuous assessments. And at the end of this course, we will have a case study. We will have some presentations and discussions that will last around 15 hours. So each one of you will have chance to give presentations, and other students will be the judge to give you marks. And so the top presentations, we will give the students the outstanding presentation awards in this course. And talking about the assessment, and we will have 2 assessments that will count 30%, the test 20%, and the case study report and the Viva examination each count for 25%, so in total 100%. So this is how this subject will be arranged in the next semester. Alright, thanks very much for listening. I'm Dr. Lin, and if you have any questions regarding to the course or regarding to the content of the course, EIE567, please leave me an email via this PolyU email address below. Thanks again, and I hope you will join this course and enjoy the learning of this subject.